What is standard Gibbs free energy? Delta degrees. Imagine you're watching a chemical reaction unfold and wondering whether it will happen on its own or need a push. That's where the idea of standard Gibbs free energy comes into play. It's a way to measure how likely a reaction is to occur without any outside influence under specific conditions. Standard Gibbs free energy, symbolized as delta degrees, tells us the energy change when reactants in their standard states turn into products also in their standard states. Standard states usually mean pure substances at 1 atmosphere pressure and a set temperature, often 25 degrees Celsius or 298 Kelvin. This helps chemists compare different reactions fairly. To understand delta degrees, we need to look at Gibbs free energy itself, which combines two key ideas, enthalpy and entropy. Enthalpy is about heat content, or how much energy is stored in bonds. Entropy measures how disordered or random a system is. The relationship is simple. G equals H minus T times S, where G is Gibbs free energy, H is enthalpy, T is temperature in Kelvin, and S is entropy. When a reaction happens, the change in Gibbs free energy, called delta G, tells us if it can happen spontaneously. If delta G is negative, the process tends to occur naturally. If it's positive, it usually won't happen without added energy. When delta G is 0, the system is at a state called equilibrium, meaning no net change is happening. Now, standard Gibbs free energy change, delta degrees, is calculated under standard conditions. It's based on the changes in enthalpy and entropy at those conditions. The formula is delta degrees equals delta degrees minus T times delta's degrees, with both delta degrees and delta's degrees measured at standard states. This value helps predict whether a reaction will favor products or reactants when everything is set to standard conditions. Delta degrees is also linked to the equilibrium constant, which tells us how far a reaction goes before stopping. The relationship is delta degrees equals minus R times T times the natural logarithm of the equilibrium constant, where R is the gas constant. If delta degrees is negative, the equilibrium favors products. If positive, reactants are favored. In the context of entropy and spontaneity, delta degrees helps us see the balance between energy releases or absorption and the increase or decrease in disorder. A reaction might absorb heat but still happen spontaneously if it greatly increases entropy. That's why reactions aren't just about heat. They're about the overall energy and disorder changes. Chemists use delta degrees values to predict how reactions will behave, how far they will go, and how to design processes that produce useful work efficiently. It's a key tool for understanding why some reactions happen naturally and others need help, all while keeping things simple and clear.